Lesson 6, Divide Whole Numbers. Today we'll learn how to do the area model, partial quotient division, and long division. Here's our first question. There are 345 fifth graders enrolled at Wilson Middle School and 15 fifth grade classrooms. How many students are in each class if each class has the same number of students? Well, because this is a word problem, I'm going to use a strategy called cubes. And that should sound familiar to some of us. Okay. The C stands for circle the numbers. Underline is the U. I'm actually going to make this a little bit thinner. We're going to underline the question. So how many students should be in each class if each class has the same number of students? B is box the math action words, and in this particular problem, each is a math action word for division. Okay, and then E, eliminate all the extra stuff, and S is for solve. So what we have now, what we just need to understand is that we have 345 fifth graders that need to be divided into 15 classrooms. Now, most kids, when I ask them what number should go in the first box, they always say the bigger number. That is not true. The size of the number is not the reason why we put it first. The reason why we put a number first is it's the thing that's being separated. It's the thing that we're cutting up or dividing. It's the thing that we're dividing. So we are separating these fifth graders into their classes. We're not going to be splitting up these classrooms. That simply doesn't make sense. So we are going to be splitting up the 345 fifth graders because they need to be split up. You can't have a class of 345 fifth graders. So we put that in the dividend. That is the number that we are dividing. Let me just make that 340. I want that to be like a 4 and 5. The divisor is whatever is doing the splitting up. So we're going to split them up into 15 classrooms. And our quotient is, of course, the answer. Okay, so we have our dividend is what we're splitting up. We're splitting up the students into their classrooms, and we want to figure out how many students are in each classroom. The first strategy I'm going to show you is the area model. Okay. It should look familiar because we worked with the multiplication model last week. So I'm going to set up my box. Okay. And the multiplication model, the factors were on the side and on top, and your product was inside the box. Well, this time 345 is the product. 345 is also the dividend. As you can see here, it is the dividend. And that goes inside the box. What we need to figure out is what other factor would make 345. So the first thing we need to do is figure out how big a chunk we can eliminate out of 345. So what I might do is set up a list of partial quotients. So I know 15 times 1 is 15. That I know by heart. 15 times 10 is the same thing with a 0 at the end. And 15 times 100 would be the same thing, but with 2 zeros at the end. And as you can see, that number is really big. That's going to be way too big for 345. We can't subtract 1,500 from 345, but we can subtract 150. So that's the first factor I'm going to use. So every time I subtract something away, I'm going to put that partial at the top. So that was 10. I'm going to put it right here at the top. Erase this one. Oops. Okay. And I'm going to subtract 5 minus nothing is still 5. 4 minus 5, I can't do that. So I'm going to have to steal from next door. They're going to be left with 2, and they're going to be able to give me 14. 14 minus 5 is 9. 2 minus 1 is 1. So now I have 195 left behind. I'm going to take that and subtract another chunk of 15 away. I can use 150 one more time. So here we go. I'm going to use 150 again. 5 minus something is 5. 9 minus 5 is 4. And 1 minus 1 is nothing, is 0. So I'm still left with a little itty bitty chunk. This time I'm going to use skip counting. 15 plus 15 let's check that. 5 plus 5 is 10. Regroup, 30. So I know 15 times 2 is 30. What if I add one more 15? Would I get to the number I need? 0 plus 5 is 5. And 3 plus 1 is 4. That is the number I need. So I know that 15 times 3 is the number I need. So 45 minus 45 is 0. And that's how you know you're done with your division. When you hit 0, that means you're done dividing. And here is our answer right here on top. That is the missing factor. 15 times whatever this is will give you 345. 10 plus 10 is 20. 20 plus 3 is 23. So that missing factor was 23. I did all of that division simply by using my powers of 10, and then a little skip counting at the end. I'm going to put my answer in that box. 23. Here's our next model, the partial quotient method, which is going to look really familiar. What you're going to do is set up a box with your divisor, and you're going to try to figure out how many groups of that divisor, so how many groups of 15 will it take to get to 345. So what I'm going to do is I'm going to multiply 15 by the powers of 10. So I'm going to set up a box. Oops, oops, oops. I don't like the way that looks. I'm going to do it like this. Okay, so I'm going to have 15 times 1 with a 0. So that's going to help us out if I just think about it like 15 times 1 with a 0. 20, 30, 40, 50, 60, and we'll stop there and see if we need any more. So 15 times 10, this is going to be 15 with a 0 on it. 15 times 2, well, that's 15 plus 15, which, as we figured out from before, that should be 30. So that means 15 times 20 is 30. And let's make that look better. 30 with a 0 on it. 15 times 3 would be 15 more, so that would be 45 with a 0 on it. Remember, our divisor, or not our divisor, our dividend is 345. Do you see a number that's close to 345? I know I do. When you see that you already have a number that's close enough, you don't actually need to keep going. I see 300. That is the perfect number for us to start off with. So, based on what I know of partial quotients, here's my division problem. 345 divided by 15. I have already located a partial quotient that would be amazing. 300 is a really good one because it's very close by. And I'm going to put my 20 outside. And I subtract. 5 minus nothing is 5. 4 minus nothing is 4. And 3 minus 3 is 0. So now I need to figure out how many 15s are in 45. Well, I'd already figured it out up here. I figured it out up here that it was going to be 45. That 15 times 3 is 45. So I'm going to put a 3 out here. And I'm going to subtract 45 down here. 45 minus 45 is, of course, 0. So we are all done with our division. And we just need to add up our partial quotients. Be really careful here, boys and girls, because I've already done a 5th grade mistake. When you put your numbers here on the side, make sure that your 1s are lined up, your 10s are lined up, and your 100s are lined up, because you might add them incorrectly. So 20 plus 3 is, of course, 23. And that is your quotient. That is your final answer. I'll try to put it down here. Yeah, that's not going to work. Okay, so we didn't need to continue in these boxes here because we already knew our dividend is 345. We already had a really good number that was close by. If you find that there's a number that's really close, that's not over, you can stop. You don't need to keep adding and multiplying. You've already found the perfect number. And this is a strategy called long division. And this one demands that you know your multiplication facts really well. Okay. So this one you ask yourself, can 15 go into 3? No. Can 15 fit into 34? Yes, it can. And not only can it fit into 34, it can fit in 2 times, because I know that 15 times 2 is 30. So I'm going to put that. So I subtract 4 minus 0 is still 4, and 3 minus 3 is 0. I still have a number here, the 5. I'm going to bring it down, because what I have left is I have 4 10s and 5 1s left in my number. How many times can 15 fit into 45? 3 times. And there you have it. I'm going to subtract, and I'm going to end up with a 0, and I know that I'm done. And so the quotient is 23. So this particular strategy is using the partial quotient method, and it's really trying to help you do things step by step, and it's telling you exactly what to do. How many groups of 5 are in 4,800? There are 900, so you're going to subtract 900. And you just keep following the instructions until you get to the end. 900. Wait a minute, that's not what it's asking me. 900, sorry boys and girls, 900 is your partial quotient. There are 900 groups. So you're going to have to figure out, okay, what is 900 times 5? And if you know what 5 times 9 is, then you'll know what 5 times 900 is. So 900 goes on top here. Sorry about that. So every time they ask you how many groups it is, that goes on top. And then you'll get your answer. For this particular problem, I'm just going to help you set up the problem so that you can divide on your own. There are, of course, a lot of things going on in every word problem, so don't forget to use your cubes method to help you figure out what's going on. A game store has 2,540 video games on 4 racks. Each rack holds the same number of video games. How many video games are on each rack? Well, first, circle the numbers. Next, underline the question. How many video games are in each rack? Box the math action word. Each is a big divisional math action word. E is eliminate all the other things, and S is for solve. So we definitely have our two numbers, and we know what operation we're doing. We are dividing. Of course, this is a division problem. What we need to figure out is which thing is being divided. Are we splitting up our video games or splitting up our racks? Think about that. If I'm a game store, imagine this is GameStop, and they have all these video games. Do you think they put all their video games on one rack? Or do they split them up and put them all over the store? Whatever number you split apart goes first. Okay, and once you have that sorted out, you can start your division problem. Use any strategy that makes sense to you. If you need help, go to the beginning of the video and watch those strategies one more time. So in this problem, we're multiplying by 14, and we need to complete the table. So one thing that you can do is skip count until you get to where you need to be. So 14 times 1 is 14. And because it's really a 10, we put a 0 at the end. So that's one thing you can do is simply add up your 14s on the side. 14 plus 14 is 28. And as you can see, we just put a 0 on the end. Add one more 14, and you're going to get whatever belongs in that box, because that's going to be 14 times 3. Down here, you're going to pick one of the numbers from up here that belongs in these boxes. So I'll do the first one so that you understand what I mean. 462 divided by 14. Ooh, I would need to look for a number that's really close to 400. It's going to be one of these two. When I figure out which one it is, I can put it in this box here. Okay, so until you figure out which one is the best the very best one for 462, we put it in that box. You're going to do the same thing for B, C, and D. So already, I can already see the one for C. C is 798 divided by 14. Do you see 700 in our table? It's right here. So that means 50 would be the very best one to pick. 60 is probably going to be way too big. 50 is probably the perfect one. Okay, so number 4 is asking you to use the partial quotient method, and it's dividing by 14. You can use the exact same table that you just completed to help you with this problem. So the work has already been done for you, just so you know. It's already been done for you in the previous problem, number 2. Okay? Alright, for these, I just want to make sure all of you understand what it says. I'm going to use cubes again. And this is really my favorite thing in the whole world, is cubes. The Mini Muffin Company bakes 1,872 muffins. The large mini muffin boxes hold a dozen muffins. How many large boxes are needed to package the muffins? First thing I have to do is circle my numbers. I don't see any other numbers. Actually, I see one that's hidden. The word dozen means 12. So that's the other number. It's actually the number 12. And it's saying all the boxes hold 12 muffins inside. So this is another one where you really need to set up your problem first before you begin. So set this up first, and then you do the math. Don't leave this last box empty. So what we need to figure out is, what are we cutting up? Or splitting up? Are we going to be splitting up the muffins or splitting up the boxes? If I'm a company, I definitely don't want my boxes to be destroyed, because that's how I hold all of my muffins. So I'm going to make sure the 12 is not getting cut up. It must be the muffins. We love to cut up food. We love to share food. We love to split it up. Food is always a good dividend. So we have 1,872 divided by 12. Okay. The little guys on the side always have really, really, really important stuff to say. He says, I think there are at least 2 steps in solving this problem. So that this is definitely a 2-stepper. The Lane School sold 1,152 granola bars to raise money for digital cameras. They sold 528 berry bars. The rest were raisin bars. The granola bars came in boxes of 24. How many boxes of each kind of granola bar did they sell? So we have 2 division problems going on here. We're going to be talking about the berry bars and the raisin bars. So before I begin, I'm going to remind myself to go through cubes. First, circle the numbers. So we have 1,152. We have 528. We have 24. Okay. And then we're going to underline our question. How many boxes of each kind of granola bar did they sell? Box math action words. So if this is a 2-step problem, that means there is 2 math action words we need to be on the lookout for. The Lane School sold the granola bars to raise money for digital cameras. They sold 528 berry bars. The rest were raisin bars. Rest sounds really familiar. What do you think rest means? We're selling all of these granola bars, and some of them were berry bars and the rest were raisin bars. What operation would we have to figure out? Which operation would we have to use to figure this out? We need to figure out how many raisin bars there were. And once you have that number, you'll have exactly how many raisin bars you need to divide. So you need to do two division problems. One for the berry bars and the other one is for the raisin bars. So you have two division problems going on. The problem is you don't have your dividend for the raisin bars yet. How are you going to figure that out? How many raisin bars do they have? You do have the berry bars, so that's good. And what are they dividing by? How are they splitting these bars up into the boxes? Make sure you're using all of your numbers. Once you have that figured out, you'll be able to do the division and answer your question. In lesson 6, we talked about the word dividend, which is what we're cutting up, splitting apart. Whatever you're cutting up into pieces, that's what goes in that box. It's never going to be the number that's biggest. That is not going to be the reason why. We talked about the divisor, the quotient, which is the answer. We also talked about the relationship between division and multiplication. The dividend is the same thing as the product. The divisor is the same thing as a factor, and the quotient is also the other factor. We use 3 strategies: the area model, partial quotient, and long division. Always remember, the dividend is whatever you're cutting apart. Your first number is whatever you're splitting apart, not the number that's biggest. It's the number we're splitting apart. That's it for lesson 6.